try to form a pattern over here. What is 1 into 1 factorial? 1 into 1 factorial, that's 1. If I add, look at the question. So if I add 2 into 2 factorial in it, what will be my summation? That is 5. Harsh, this is the starting point, first screen for today. Add 3 into 3 factorial in it. What do you get? 3 factorial is 6. 6 3s are 18. 18 plus earlier value of 5. 18 plus 5, that becomes 23. Correct? Add 4 into 4 factorial in it. I get a 119 total. Add 5 into 5 factorial in it. What's 5 into 5 factorial? That's 600. So total becomes 719. So observe these numbers. Is there a common observation that you can make? Any common observation that you can make? Yes, what is that? So it's next factorial minus 1. Absolutely right. So can I say 2 factorial minus 1, 3 factorial minus 1, 4 factorial minus 1, 5 factorial, 6 factorial, and so on. So if I go on adding up till 12 into 12 factorial, can I say directly that this will be 13 factorial minus 1? Correct? Can I say it is 13 factorial minus 1? So 13 factorial minus 1 is equal to P. Let's look at the question. P is equal to 13 factorial minus 1. So P plus 3 will be what? 13 factorial minus 1 plus 3. That's 13 factorial plus 2. Correct? 13 factorial plus 2. Now 13 factorial plus 2, divide it by 13 factorial. So 13 factorial plus 2 divided by 13 factorial. Can I say 2 will be the remainder? Rest of the part is completely divisible, making my remainder 2. Clear, everyone? Yes or no? With me? Once again, okay? So, till this part clear, Ravi? Vishnuvardhan, till this part is clear? So, after this, I can say that P plus 3 will be 13 factorial minus 1 plus 3. That is 13 factorial plus 2. Correct? So when I divide 13 factorial plus 2 by 13 factorial, I can say that the first part is completely divisible. So whatever is the remainder should be there in the second part. Example, 7, or let's not take factorial, let's take 7 plus 2. When I'm dividing it by 7, my remainder should be 2 only. Can I say? Right? Same logic, 13 factorial plus 2 divided by 13 factorial, 2 should be the remainder. Now clear everyone? Remainder, Pushkar, remainder. ठीक है? चलो. How could we have solved mathematically? So this was by observation pattern. How could we have done mathematically is we know n into n factorial is equal to, say for example, 8 into 8 factorial is equal to 9 factorial minus 8 factorial. Because 8 is 9 minus 1, then split it open. 9 into 8 factorial is 9 factorial. 1 into 8 factorial is 8 factorial. So this becomes 9 factorial minus 8 factorial. Similarly, anything would become, for example, 7 into 7 factorial will become 8 factorial minus 7 factorial. Then 7 minus 6, 6 minus 5, 5 minus 4, and so on. It will continue. So in general, this can be written as 2 minus 1, 3 minus 2, 4 minus 3, and 5 minus 4, and so on. Then there would be cancellations. So one term remaining over here is this, and one term remaining over here is this. So 13 factorial minus 1 factorial, that's same thing now. Value of p is this, so p plus 3 would be 13 factorial plus 2, and as earlier, a remainder of 2. Okay? All right, done. Can we go to next, Surya? So if you want, you guys can take a screenshot as we progress, right? If you want to keep it saved, some particular point you like and you want to keep it with you, then you can take a screenshot. Okay. All right, Pushkar. Let's see. 7 factorial. How can we find 7 factorial? We have already done that, right? 7 factorial was 5040. 3 factorial plus 4 factorial plus 5 factorial. Of reference. 0 is my point of reference. So from that origin, whatever is the distance of my point, that is considered to denote that point. Example, I'll give you example. Say I want a point which is at a distance of 5 units from the origin. I want to find a point which is at a distance of 5 units from origin. So 5 units can be here as well, or 5 units can be here as well. So when I say a point at a distance of 5 units from origin, it could be plus 5 or minus 5, either of them. And that is your concept of modulus. How? Acha, modulus जाने से पहले I think there is square root function, okay? Let's look at the square root function before going on to modulus. So square root, all of us are aware. How would you plot root 16 on the number line? What is root 16? So what I should do is plot it over here. Now, some of you may also say that root 16 can also be written as minus 4. Correct? Root 16 can also be written as minus 4. Then why only plus 4? The reason is the square root of a number is always defined as positive square root unless and otherwise specified. So unless and otherwise specifically the question mentions it somewhere, I will consider the root to be positive only. Okay? That means negative is not wrong, but by convention, we take only positive, and we will take negative only and only when it is specified in the question. Okay? Clear, guys? Can we go to next? Try this. Sorry, just a second. Not this. Just a second. Slide. नहीं slide change नहीं हुआ. Just a second. Okay, example slide is not there. It's not coming. Okay, we'll come back to other examples later. Let's study greatest integer and least integer functions. Don't worry, more examples are there at the end. Greatest integer and least integer functions. So how do I define a greatest integer function? A greatest integer function is defined as x in a box. And what does that box bracket represent? It's like I want an integer which is less than or equal to x. For example, greatest integer of 3.78. So I want an integer which is less than or equal to 3.78. So what is less than or equal to 3.78? And integer. Three, correct. So the first integer that I have less than 3.78 is 3. So value for this is 3. Similarly, minus 5, less than or equal to minus 5, which is the first integer that you come across. Yes, it is minus 5. Minus 5 itself is an integer, right? So it will be minus 5 because equal to is possible. 3 root 3. What is the value of 3 root 3? Three root 3 is equal to 3 into 1.73. That is 3 into 1.73. That is approximately 5.19. So when I'm looking for greatest integer of 5.19, I should be looking at 5 because I want an integer which is less than 5.19. See, it's kind of like this. Let's take another example. Say minus 2 pi. What's the value of minus 2 pi? Pi is 3.14 approximately. Double of it is 6.28 approximately with a negative. Right? So question number 1, tell me how which are the integers which are less than minus 6.28? Which are the integers? Minus 7 to infinity, correct. It's minus 7, minus 8, minus 9, minus 10, up to minus infinity. All of these numbers are less than minus 6.28. And amongst all these numbers, which is the greatest one? Amongst all these numbers, which is the greatest one? Minus 7. Yes. So that's how I'll find out greatest integer. Okay. I'll give you another shortcut for this as well. So in a greatest integer function, what you should do is plot the point on the number line and go to the left. Whichever is the first integer that you come across has to be your answer. Whichever is the first integer that you come across has to be your answer. Clear? Use of this, you will see. There will be questions based on it in maybe module 4, sometimes in module 2. It is useful. It's kind of a step function. So when you learn functions, so that time you will see this. Okay. Next. Similarly, for any real number x, we defined L of x as the least integer, which is exactly opposite of what we just did. That is, earlier I was going to the left on the number line, so now I should go on the right on the number line. So example, least integer of 3.78. So what is an integer that is to the right of 3.78? Pushkar, this is module 1. So 4, correct. 3.78 के right में the first integer that I come across will be 4. Least integer of -5. That will be -5 itself because it is an integer already. So it will be -5. 3 root 3. That's 5.19. To the right of 5.19, what will be there? 6, correct. So first would be 6. Least integer of -2 pi would be what? -6, correct, because it is -6.28. Go to the right from there. The first integer that you come across would be -6.28. So for least integer, you go to the left on the number line, and for greatest integer, you go to the left. Least integer, you go to the right. Okay? Understood? Unless it is integer itself. In that case, the integer itself will be the value. Clear now? Can we go to next? So this is, as I said, going to the left or going to the right. Another name for greatest integer is round down or floor, and least integer ka another name is round up or ceiling function. Modulus function. Modulus is basically distance between any two numbers. For example, if I say Mumbai-Delhi distance is 1400 kilometers, then it means that Delhi-Mumbai distance is also 14 kilometers. Suryank, names are not that relevant. It's okay. However, the names are greatest would be round down or floor, and the other one, least integer, would be round up or ceiling. So in such cases, we wish to ensure that the number is non-negative because my distance should never be negative. Mumbai-Delhi is also plus 1400. Delhi-Mumbai is also plus 1400. Right? Let's look at the number line. So if I want a point which is at a distance of 6 units from origin, so it could be either here or it could also be over here. When I want a point which is at a distance of 6 units from origin, it could be either of them, right? So let's say let's say I'm talking about a point this x equal to -6. So distance of this point from origin is 6 units. So how can I get that 6 units? When I put a mod on both the sides. Because mod of -6 is equal to 6. So that means when I put a mod around my variable, that basically means I'm counting the distance of my variable from origin. I'm counting the distance from origin, right? So there can be two numbers which are equidistant from origin because mod of 6 is also 6, mod of -6 is also 6. So there can be two numbers which are equidistant. In geometric terms, a minus b ka mod can be seen as distance between a and b. So for example, I have a 2 and a 7. So mod of 2 minus 7 is like distance between 2 and 7. That's 5 units. Like this. Okay. Similarly, 5 plus 3 can be looked at as 5 minus minus 3 ka mod because I want it in the form a minus b. So that is distance between 5 and -3 is 8. Okay. In shortcut, in a shortcut, what I can say is modulus basically converts negative into positive and positive remains positive. That's it. Okay. So find x if mod x is 3.5. So if mod x is 3.5, that means I can say that the distance of my point from origin is 3.5. But in which direction can I say? Can I say that this distance is in which direction? No. So that's why positive or negative, both values of x are acceptable. That's why x would be plus 3.5 or x would be minus 3.5. Okay? All right, China, join in. China, lots of things are done. So just wait for some time. I'm sure you will catch up. Later on, you can check the recording. So, acha, if 2x plus 1 equal to 7, then there are two choices. Either 2x plus 1 equal to 7 or 2x plus 1 equal to -7. Just the way I split above mod, when mod x equal to 3.5, I said x equal to 3.5 or x equal to -3.5. Similarly, here I can say 2x plus 1 is 7 or 2x plus 1 is -7. So if I say 2x plus 1 equal to 7, then x equal to what? X becomes 3. And if I say 2x plus 1 is -7, then x equal to what? -4. Because one shifts to the other side. So I get -7 minus 1, that's -8. 2x minus 8, so x equal to -4, I can say. Right? Find x if mod of 4x minus 9 equal to 3. Mod of 4x minus 9 is equal to 3. Same thing I should do. Either 4x minus 9 is equal to 3 or 4x minus 9 is equal to -3. So I get x equal to 3 or x equal to, what would be the other value? 1.5 or 3 by 2, correct. 3 by 2, not 2 by 3. ठीक है? Tell me this. It is not possible. You guys need not solve it. It is not possible. Because how can a mod be negative? That contradicts with my definition, right? Modulus will always give me a positive value. Right? So this one is simply not possible. Okay? Clear so far? Okay, next one that we know is Bodmas rule. What is Bodmas rule? B stands for vinculum. B is bracket of division, multiplication, addition, and subtraction. So that means your mathematical operations have to be performed in this manner only. That is, your B is bracket. So your bracket gets a priority over division. Division gets a priority over addition, and so on. Okay. So you may ask, what is B for vinculum? So B for vinculum is actually the bar. Example. Say, अच्छा bar is not there. ठीक है, चलो देखते हैं फिर भी. 17.3 plus 8.2 into bracket 2 minus 1 plus 4.5. So what should I do first? What stands in line first? Bracket is the first thing. Bracket is the first thing. So go for bracket 2 minus 1, that is 1. So then I get multiplication should be priority then. So I get this. Post which it's addition and addition. So you can do it together. Addition becomes 30. Clear? So try this. So here the bar which is there above 4 minus 7, that is called as vinculum. So that gets the highest priority. And by the way, what does off mean? In the BODMAS, BODMAS, O stands for off. And what's the meaning of off? Multiply. But then off also means multiply, and multiply also means multiply. So what should I do when there are both? Which one to get priority? 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. Add all of them. 6 plus 24 plus 120, that is 150, correct? How about this? So that's 1 into 1 into 2 into 6. 1, 1, 2, 6. Product is 12. Next. What I can do over here is take 6 factorial common. 3 plus 4 becomes 7. 3 plus 4 becomes 7. So 7 into 6 factorial becomes 7 factorial. Right? Which is 5040. Cool. Next. This we have just done. Already done this. N can be written as n plus 1 factorial minus 1, n plus 1 minus 1. That is n plus 1 into n factorial minus n factorial. That is n plus 1 factorial minus n factorial. Already done this. Some other useful terms. When I'm talking about a real number line, any real number line is a way of representing example. Example, say something like this. So here, let's say 0 is my point of the one where off is written in words should get the priority because off gets a priority over normal multiplication. Clear? Okay, so let's try this one. What is 4 minus 7? Here off is not there, Rahul. I'm saying in general. 4 minus 7 is minus 3. 7. Acha, now I should go for bracket. So bracket mein there are two brackets, so I can solve them separately. So in one of the brackets, I get division and multiplication, and there is another bracket. So what should I do? Bracket ke andar ka bracket should be solved first. The priority should be to innermost bracket first. So I get something like this. Second bracket I solved simultaneously. Now still there is a bracket, so it should get a priority. So how much is 62 by 20? 3.1. So I get something like this. Now division and subtraction, who gets a priority? Division. So calculate this, it comes out to be 4, and 4 minus 4 is 0. So final answer 0. Understood? Clear hai? All right. So rest of the questions for this, I would suggest that you guys try at home once. Okay? You have the modules. Even if you don't have the physical copies, you still have the online books. So I would suggest that go for class exercise Q.A 1.1 and do the remaining questions of board mass as a homework. Okay? Try this now. Plot the following points. But what I'll do is I'll not actually plot the points. I'll just do calculate them. So 3.14 is 3.14. 4 by 6 is 0.66. What will be least integer of root 2? Yes, it will be 2. Because least integer of root 2 is 1.41 ka least integer, that is 2, correct. Mod of minus 5. Suryank, we will get that in the third chapter. Mod of minus 5 will be plus 5. Then root 16 can be marked at 4. Minus 3.2 wherever it is. 0.33 wherever it is. Mod of 3.14. Mod of 3.14. Sorry, not mod. That's greatest integer. Sorry, my bad. Greatest integer of 3.14. That will be 3. And greatest integer of minus 3.14. That is minus 4. See, look at the last point I, it is denoted at minus 4. Okay? Try this. Srinivas, no, it will be minus 4. Multiple answers, no, Rahul, it's going to be a single answer. Combine all of them. Srinivas, minus 3.14 should lie somewhere over here. So what lies to the left of minus 3.14? Minus 4. Understood? Because greatest integer may we go to the left. Okay? So here the first one is 3.2, second one is 3.2, third one is 3, fourth one is minus 4. Right? So 6.4 plus 3, 9.4 minus 4, 5.4. Got it? All of you got the answer right? Next. Achha, sorry, this one. Pushkar, yes, I can see that. However, every time I would be going through all the answers. It's okay. You can verify it for yourself. Sometimes I will go through your answers. Sometimes I will give it to you directly. Okay. So minus 4.7 ka greatest integer is what? Bracket means greatest integer, yes. Square bracket, greatest integer. L is least. So minus 4.7 ka greatest integer is minus 5. 3.2 ka least integer is going to the right, 4. Minus 2 ka mod is 2. And least integer of minus 1.735, go to the right, minus 1. So minus minus became plus. 5 into 4, 20 into 2, 40. So plus 40 becomes my answer. Okay? How about this? Zero? No, not zero for sure. 10. No, Akshay, I don't think so. Yes, Nihal, Shubham, Samarth, yes. This one is right. So how I can do this is, First, modulus of greatest integer of minus 4.6. That is greatest integer of minus 4.6. Go to the left. I get minus 5. And then mod, I will get plus 5. Second, mod of minus 4.6 becomes plus 4.6. And then plus 4.6 go to the left because of greatest integer. So 4.6 ke left mein lies 4. So 5 plus 4, that is 9. Got it? Chalo, next. Mod of 3.2 minus 4.8. That's mod of minus 1.6. That is plus 1.6. Right? Can we go to next? State true, false, or cannot be determined. True, false, or cannot be determined. Try this. So there are 20 integer values of x such that mod x is less than equal to 10. Mod x is less than equal to 10. True or a false? What's 0? You have to find out whether it's true or a false. This one is false. This one is false, guys. Why? Because, yes, including 0, it is 21. Correct, Harsh. That is right. No, not infinite. Integers are limited. See, mod x less than equal to 10. Let's think in geometric terms. What does it mean? That distance of my point from origin should be less than equal to 10. So can I say 10 units to the right and 10 units to the left? My point should be somewhere in between. So my values could be 10 units to the right. That's 1, 2, 3, 4, 5 up to 10. Similarly to the left, minus 1, minus 2, minus 3 up to minus 10. So that's 20 values and a 0. That makes my total number of values 21. Okay? So the statement is false. Agreed, everyone? Try next. How about this? First one on the slide, Ravi. Okay. See, what I want is mod x less than equal to 10. That means I want my point to be at a distance of 10 units or less from origin. So can I say my point should be within this range? Equal to 10 is there. That means these points are also included. So 0 to 10, that's 1, 2, 3, 4, 5, 6 up to 10. And minus 1, minus 2, minus 3 up to minus 10. So 10 positive, 10 negative, total 20. And the middle value 0. That's 21. So that's why total values are 21. Hence the statement is false. Okay? Nihal, check again. Mod of minus 20 becomes plus 20. Is it less? No, right? Okay. Coming to the second question, a lot of you have given the answer true, a lot of you have given the answer false. Both sided answers are there. Is there anyone who has said CBD? There are lots of trues and lots of falses I can see. But is there any CBD also? Oh, CBD is there. Aditya, okay. Nihal, okay. So guys, can you think of the logic? Everyone who is saying true, who is saying false, and who is saying CBD. I want all of you to think of the logic for a moment. Let's think. If I say the statement is true, then the statement should be true in all the cases. If I say the statement is false, then the statement should be false in all the cases. And if I say CBD, then it cannot be determined, right? So, acha, one more thing over here. This is if-then kind of statement. And how do you check validity of any if-then kind of statement? Let me give you an example. Say, if I wear a green shirt today, then it will rain. Again, repeating the sentence. If I wear a green shirt today, then it will rain. Okay. This is my statement. So now let me evaluate this statement, whether it's true or false. So I go out there wearing a green shirt and it rains. So my statement becomes true, right? If I wear a green shirt, go out and it doesn't rain, that means my statement became false, correct? But if I wear a blue shirt and it rains, or if I wear a blue shirt and it doesn't rain, what can I say in that case? Say I wear a blue shirt today and it rains. What can I say? Can you tell whether my earlier statement was true or not? No, because my earlier statement was based on an assumption that you are wearing a green shirt. If you're not wearing a green shirt, then what will happen outside? I don't know. Right? Because whether it will rain or it won't rain was dependent on whether you wear that green shirt or not. But when you decide not to wear the green shirt, then do I know what is the connection between blue shirt and the rain? Maybe for blue, the relation is reversed. That is, whenever you don't wear blue, it will rain, or whenever you wear a blue, it will rain, whatever. Right? So that means whenever I have to whenever I have to validate any if-then kind of statement, my if part has to be true always. See, it's like जब तक मैं green shirt नहीं पहनता, तब तक I am not able to verify whether the sentence is true or not. Right? So that's why whenever I'm trying to verify if-then kind of statement, my if part always has to be true. Then only I can verify the then part. Okay? But sir, in the logic, if A then B, then we can conclude if not B, then it is not A. But that's not the case over here. See, I am not trying to identify, see, it's like, okay. Let me put it like this. This statement is given to you already. Now, Richa, what you're saying is, if A, then B. But does it mean that if A, then and only then B? Can't B happen otherwise? Can't B happen otherwise? Let me give you an example. If it's the month of July, then it is going to rain. If it is the month of July, then it is going to rain. Does this statement anywhere means that it cannot rain in any other months? No, right? So let's say it is the month of August. Will it rain? My statement is if it is the month of July, then it will rain. Let's assume the statement is true. So if it is the month of August, will it rain? Maybe. It can. हो सकता है. That means cannot be determined. Because हो सकता है का मतलब नहीं भी हो सकता है. Maybe is equal to may not be. Right? So again, so to verify my sentence, my if part has to be true. So that means I cannot make an observation about the month of August or September and then verify whether my July wala statement was true or not. To verify that sentence, I must consider a date in the month of July and then verify. Say July 20th, it rained. So statement true. Or July 21st, it did not rain. So statement false. Something like that. Understood? So number one, to verify any if then kind of statement, my if part always has to be true. Okay? Second, now let's consider my if part is true. Let's say I'm talking about the month of July. So July 20th, it rained. Does that ensure that if it is the month of July, then it will rain? I checked one value, July 20, it rained. So can I make a conclusion that if it is the month of July, then it will rain? Can I make this conclusion? No. Because it may happen that on that particular day it rained, but on other days it is not raining. It's possible. So if I want that statement to be true, then I want it to be true for all the possible values in July. Similarly, if I say that my statement is false, then it must be false in all the possible values in July. It should not be true even for a single day. मतलब जुलाई में एक भी दिन बारिश नहीं होना चाहिए. Then I will say that the statement is false. या जुलाई में every day बारिश होना चाहिए. Then I will say that statement is true. But say if one day rain happens, other day rain doesn't happen, then what should I say? Out of the 30 days, 20th July rained, 21st July did not rain. What should I say? Then directly cannot be determined. I don't need to check for third value. One true, one false, CBD. All true, definitely true. All false, definitely false. One true, one false, CBD. Okay? No, Pushkar, I will not be teaching all this in LR because this is not actually a part of LR. This will be part of critical reasoning, which comes under verbal. So your verbal faculty most probably will take care of that. Okay? Who's your verbal faculty, by the way? Have you met your verbal faculty as of now or not yet? Rachana ma'am. All right. Okay. Okay, Rachana ma'am. Fine, thank you. Okay. So Samarth, I was saying that if your if part is false, then I cannot check the statement at all. If my if part is false, then I cannot validate whether my statement is true or false. See, it's again, same thing. If it's the month of July, then it will rain. This is my sentence. So that means, can I talk about August? Can I talk about May? Can I talk about April? No, right? So that means I have to have a value which makes my if part true. I cannot accept a value to verify my statement whether when my if part is false. So it's not true, it's not false, it's not CBD. I'll simply say the value is not acceptable. Give me another value to check. I cannot check with this value. Give me another value. Getting it? Now that we have understood very well what this if then kind of statement means and everything, so now let's try to understand this. If mod of x plus y is less than equal to 10 and mod xy is less than 100, then what happens? Is the statement true or false? Check. So can you guys tell me one value where the statement is true? Remember, your if then has to be always true. So tell me one value where this statement becomes true. One value of x and y. Anything 5 and a 4, yeah? Why not 5 and a 4? So I take this 5, I take this 4. So 5 plus 4 is less than equal to 10. So value is acceptable, number one. 5 fours are 20, which is less than 100. So statement became true. Can you tell me one value where it is false? Let's try to take a value where it is false. Yes, let's say plus 20 and a minus 20. So plus 20 and minus 20 adds up to 0, which is less than equal to 10. So value is acceptable, number one. Number two, multiply them. 20 into minus 20 becomes minus 400. Mod of minus 400 becomes plus 400. And plus 400 is not less than 100. So statement became false for this. So one time true, one time false. Statement is CBD. My original statement became CBD. Okay? Clear? All right. Can we say that x and y less than 5, then it will be true? Yes, based on conditions, it might be true. Just a second. Okay. Samath, yes. So as I was saying that if x and y both are less than 5, then it will be true. But I'm not looking at any conditions at this moment. The question is not saying about any such conditions. So when I'm talking in general, then the statement has to be CBD. Okay? But less than 5 may also, can we have any value like that? नहीं, actually less than 5 में नहीं होगा. It will always be true for less than 5. ठीक है. All right. Next one. Let's talk about challengers. Rakshit, now it should be visible. So we have already done one such type of question, right? 1 into 1 factorial, 2 into 2, 3 into 3 factorial, 4 into 4 factorial, and so on. So what is this product? We have already seen. As per the pattern, you remember? Can you tell me directly? 11 factorial minus 1. We remember the pattern. We have just did this few moments before, right? This one. Okay. Next. Try this one. Try this one. The number of people writing a test is a prime number less than 200. The number of people passed to those who fail, ratio of people who pass to fail could be. If I take this as my ratio, then what would be my total number of students? Can you tell me? If this is my ratio of pass to fail, then total number of students are 165 Is it a prime number 165? Definitely not. How about this 75 plus 78? That will be 160. Sorry, कितना आएगा? 40 plus 13, 153. Is 153 a prime number? No, it is divisible by 17. 17 nines are. Or 3, yes, 3 से भी divisible है. Correct. 51 threes are. Correct. So no. How about this? What's the total? 157. Is it a prime number? We check prime number का condition क्या था? Approximate square root. So I have to check over here by 2, 3, 5, 7 and 11. Because 13 square 169 is greater than this. 2 is not divisible. 157 by 3 not divisible. 5 not divisible. 7 check. 140 plus 17 no, not divisible. 11 not divisible. This is a prime number. So yes. And if you check this again, then no, because both the numbers are divisible by 13. So addition should also be divisible by 13. So this one is also no. So it's third. ठीक है? Clear, guys? Yes, Nihal, and we will be learning divisibility test shortly today. How about this one? Try this. The post office has stamps 1, 3, and 7. Which of the following totals cannot be achieved by buying exactly 100 stamps? Exactly 100 stamps. How can I do this? There would be so many possible combinations. Obviously, trial and error is not going to be the way forward. So, Vaibhav, Nihal, what was your logic behind this answer? Number not divisible by 1, 3, 7, 11. Why? Why should I look at that? Nihal, not into, it should be plus. Rest of it is okay, but not into, it should be plus. Right? So what should I do over here? I have a 1 rupee ka stamp, 3 rupee ka stamp, and 7 rupee ka stamp. Let's say there are X, Y, and Z number of stamps. Total stamps are 100. So how can I break up 100? 100 can be achieved in two ways, either even, 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 or 100 could be achieved in even, odd, odd. Only two ways to achieve, right? Only two ways to achieve. I cannot have all three as odd, or I cannot have only single one as odd. So that's it. These many ways are there. Now these numbers, number of stamps are multiplied by values, and values, all three of them are odd. All three of them are odd. So now you will say, I don't know, sir, 1 rupee wala even hai. If I'm talking about the second case, 1 rupee wala even hai, ki 3 rupee wala even hai, ki 7 rupee wala even hai. But that doesn't matter because I am not taking the exact values. I am just taking the fact that all of them are odd. So it doesn't matter whether first one is even or second is even or third is even. Right? So what is even plus odd? Even into odd. Even. Even into odd, even. Even into odd, even. What is the addition? Even. What about the second case? Even into odd is even. Odd into odd is odd. Odd into odd is odd. Even or odd. Addition is again even. So can I say in both the cases, my total sum must always be even? And if my total sum must always be even, then it can never be odd. So the odd total which is there in options can never ever be achieved. Can I say that? Right? Next. Yes, the logic is okay. Didn't get this, Richa? Okay, then try this logic. What is common to all the numbers 1, 3, and 7? All of them are odd. So basically, what I'm doing is 100 stamps, each with odd denomination, I'm adding. So odd plus odd plus odd plus odd, even number of times. 100 times, that is even number of times. So odd, 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 even number of times becomes even. So total has to be even. So 298 possible, 600 possible, 440 possible, 473 not possible. Okay? Yes, correct, Pushkar. Got it? Try this. Try this question. So multiple answers so far. Let's see. Okay, you can take values or you can do it logically as well. So one option is there, of course, correct, that you can take values, distinct integer, odd and positive. So let's take them as maybe 135. All of them are odd and positive. Least possibility 135. And then verify the options. Or what I can do is odd, odd, and odd. So odd plus odd is even. And any even number in a multiplication will always make my entire multiplication even. So this odd plus odd even will always make my entire multiplication even. So second statement should be true without a doubt, right? All right. And last, try last. Let's see. Which of the following you think is the easiest option to check? Multiple options are there. So which of the following you think is the easiest option to check? Third. How third here? Third looks the most difficult option to check. You don't know X, you don't know Y. There are two variables. That itself is the critical starting point. So easiest option to check would be the first one because there is equal to sign, not greater than, not less than, no inequality, equality. And equality is always easy to check. Mod of X minus least integer of, mod name, greatest integer of X minus least integer of X is equal to -1. Is it always true? What happens if I put integer over there? Say greatest integer of 5 minus least integer of 5. What would happen then? 5 minus 5, that is 0. So it would become 0. So it is not always -1. So the first statement became false for sure. Right? Which is the second easiest one to check? Second option itself is the easier one. Let's try second one. If I say greatest integer of X plus mod of X is greater than equal to 0. See, in all these questions now, try to have a negative mindset. That means you try to make it false. False wale examples agar mil gaye, then it's very good because true wale examples, that's our natural tendency to find it out quickly. Just say, if I ask you, tell me one example where it is true. Tell me. For any positive value, it will be true because for any positive value, first part will be positive, second part will be positive. Positive plus positive is positive, that is greater than 0. So statement true for any positive. So then let me try for negative numbers then. Acha, so there are three parts: positive or integer or negative. So let me try for negative part then. Let's say I put a value, say minus 6.5. So minus 6.5 ka greatest integer plus mod of minus 6.5. What will it be? This will be minus 7 and this will be plus 6.5. Overall, it will be negative 0.5, which is not greater than equal to 0. Which is not greater than equal to 0. So my statement became false. Right? What about next? L of x plus mod of x is greater than equal to 0. Similar to this, pretty similar to this. Again, same logic that if I put positive, then positive plus positive will be greater than 0. So no problem. So better let's try for negative. Negative may, if I put least integer of x, let's use the same value, minus 6.5. What will be the least integer of minus 6.5? Minus 6. Then after minus 6, here I can have mod of minus 6.5, that is plus 6.5, that is 0.5, which is greater than 0, right? So for positive, it was definitely true. For integer, if I'm talking about positive integer, then definitely true. If I'm talking about negative integer, say minus 6, then it will be minus 6 ka least integer minus 6 and mod is plus 6. So minus 6 plus 6, 0, which is equal to 0, which is still acceptable. So only thing that is remaining is negative non-integer. So that we checked 6.5. So for which it came out to be true. That means for all the numbers it is coming out to be true. Positive के लिए true, positive integer के लिए true, negative integer के लिए true, negative decimal के लिए true. What else is there in the world? Nothing. So always true. Got it? Clear hai everyone? Absolutely clear. Can we go to next? Let me know if any doubt you have. Okay? All right. So with this question, we end our first chapter. And now we will be moving on to second chapter, that is HCF LCM.